Hello, everybody. Welcome. Hi, guys. Good to see you all in here. Awesome. Thanks, guys, for coming. Awesome. Cool. We've got a few people coming in slowly. Great to see you guys. Cool. If you can hear me and if you are if you're here and ready to go, feel free to say hi in the chat. GM, everyone. Hi, Joshua. Hello. Hi, Zoe. Hello from Berlin. Hello from London. So we are doing session 4 of this Encode and Polkadot Educate series. Today we have Joshua from Phala talking about how to use ink in Phat Contracts. And I think we might be having a quick brief look at Swanky as well, but mostly focusing on ink. Hi, cool. Good to see people coming in as well. Nice. Fantastic. So, Joshua, while you are getting your other screen ready, do you need to get your other screen in, by the way? Cool. I've just put Joshua's Twitter in the chat. But other than that, I think you're pretty much ready, right? So when you are, take it away.
Awesome. Yeah, thank you. So let's get all right. Hi, everybody. My name is Joshua. I'm the dev advocate and dApp developer at Phala Network. So today I'm going to talk about how to use ink and a little bit of some of the Swanky integrations that we've done with our CLI tool that's based off of our community member that has contributed to our network called 100K. He built this CLI tool called DevPHAse, and we are currently integrating DevPHAse into Swanky so that you can have like a CLI tool to be able to run some commands. And I'll show like the initial setups for that here in a second. Let's see. Let's go to the next. Oh yeah, and here's some like small information about me. Typically, I have most like usernames as #warlock. So if you look around, you can find me. Typically, I'll have a picture like this or one of my utils from UtilDAO. I'll leave this up for a little bit. So if you have any questions or some technical questions during the presentation, you can jump into our Discord server and ask them in our dev channel. There we can get some of the answers to you, or if you have any questions that are maybe outside of the scope when it comes to like maybe some use cases or some of the architectural designs that we have that you want to like learn a little bit more about, you can ask there in the dev channel. Here is also another repo. So this is our awesome Phat Contracts GitHub repo. You can check this QR code here. It's also going to be in our Phala Network GitHub repository. This will be one of the repos that you can search for as well. And another link here will be the Phat Contracts UI. So I will show you the Phat Contracts UI because it's easier to kind of visualize what's going on with some of the CLI tools and being able to deploy your Phat contract onto a testnet. So I'll show an example of this as well and being able to interact with your Phat contracts. And the two tools that we'll be working with today, the Swanky Phala plugin is the tool that I've been working with that plugs into the Swanky plugin that I'm sure all of you have already gotten a demo with the SR team. They've done a really good job with the Swanky plugin, and there's what's really cool about it is that it's built on top of the Open CLI framework tool that's open source. And if you look up like I'll put it in the chat, but if you look up OCLIF in GitHub. You can find the GitHub repo, and there's a lot of documentation as well that will show you how you can actually plug into Swanky as well. So if you have an implementation that maybe can extend off of the Swanky plugin, then you can easily plug in your CLI tool into their Swanky plugin without having to change any code or anything like that. The other QR code here, DevPHAse. This is the effort from our internal community member, 100K. He did a really fantastic job building this CLI tool so that you can run these like quick end-to-end like tests on your Phat contracts before you even deploy it. It'll run like a local test net, deploy your contract, test it based off of the test that you configured. And I kind of sort of extended some features of that with the Swanky integration so that you can auto generate a Phat contract based on the name that you choose, and then be able to have a test folder and run a test really quick. So that's kind of what I'll show mostly today. Are there any questions from the audience or anything right now, just before we get kind of started? The first parts I'll sort of go into like a quick high level overview of Phala Network. Yeah, don't be afraid to ask questions also. And if you want to ask questions like in the Discord, you can also ask there. Let's go to the next part. So what is Phala Network? So this is just like kind of like a little table to kind of show you what we're solving and what Phala Network is. So Phala Network is a Web3 computing cloud. We are extending that trustless on-chain computation model that you've seen in blockchain today, and then utilizing also the aspects of like the traditional Web2 cloud, where you have this privacy and scalability. And then this is where we kind of like create this new paradigm where we can extend that on-chain trustless model to the off-chain world, so that you can actually build these like scalable applications and also like utilize like security and privacy features from our architecture based on the secure enclave off-chain workers that we utilize. So in this next part, I'll go into like kind of describing just like the high level. I don't want to get into too deep into this part since it's like a little like off of the topic, but just to show that we utilize these secure enclaves to scale our computational needs off chain. And since we can do this allows us to get access to off-chain resources like through HTTPS requests. And then since we have this hardware-based memory encryption aspect, we can utilize like storing some secrets within these off-chain workers and be able to store some keys to be able to say send HTTP requests to like on finality RPC node with our API key that's stored in the contract, and then be able to retrieve information from there to be able to compose extrinsics or something like that. It opens up the door for a lot of things that typically today most Web3 developers will use a centralized server or their own server at home to be able to make up for some of the limitations today that exist whenever you're building your Web3 dApps. So this is kind of like the real power that we are starting to show, and I'm excited to show you a little bit more as we move forward with this workshop. So as I said before, off-chain computation is what we do, and if there's anybody that has any questions right now that like just based on that little high-level overview, you can ask a question and I can answer. I saw somebody typing, so feel free. Okay, cool. So now we're gonna I'm gonna dive into the Phat Contracts typically I'm sure that you've attended the workshop with Astar. We in our Phat Contracts we also support the Inc EDSL written in Rust, and this is part of the contracts palette that's developed by Parity, and we have extended that and had some modifications to be able to run this contracts palette into inside these secure enclave off-chain workers, so that you can write in Inc and be able to also get some additional features from some of the chain extensions, whether the chain extensions that we offer, which are the signing extension for deriving key pairs and being able to sign and verify like different types of messages, or say you want to sign an extrinsic that you compose and send it to RPC node, you can do that. Along with our HTTP extension as well, that allows us to send HTTPS requests from our off-chain workers and from your Phat contract. And then we also have some crates available as well, like Pink S3, which allows you to connect to some off-chain storage to populate a key value database. And right now, the Pink S3 supports Filecoin. I think it's like storage, like STORJ, Arweave, and if you want AWS S3. Another crate that we also support is it's the Pink Web3, and the Pink Web3 is being able to interact with an RPC node on EVM-based chain, be able to derive key pairs for like an EVM address, and then compose extrinsics, and then interact with the EVM chains as well. We also have sub-RPC, which is the same thing, but for substrate-based chains. These are just like some high level. I won't go too far into this, but essentially here it's showing you the steps of how our gatekeepers right here. As you can see, they have a key, like what's it called, a key generation phase, where they are gonna generate a key, and then from this root key that they've agreed upon during this phase, we will then generate and derive cluster keys for each cluster, and each cluster can have one to many off-chain workers. And from there, the cluster key will then derive these contract keys, which will be representative of your Phat contract ID. And from there, you'll have your you'll be able to upload your code, instantiate your contract, get your key, and then be able to interact with your contract as well. I won't go too much further into this, but it's just like a little slide for you to look at it. Some of the I need to change some of the wording, but just some comparisons to like traditional smart contracts versus the Phat contracts. Typically, you're gonna have to wait for a consensus of all the nodes for a smart contract to which then in turn leads to some latency. So typically, the power of the Phat contracts is that we typically are allowing you to build these serverless applications. So since they're serverless, how we can have this latency of 0 seconds when it comes to like interaction with your off-chain worker, most of the power is in our queries. So whenever you're sending an HTTP request, it's recommended and mostly enforced that you should use the queries, because from there you can directly interact with and send your HTTPS requests immediately whenever you're writing your Phat contract code. And I'll show some examples of this as well. Your computing power is also scalable now. So instead of like every worker doing the same computation, you can distribute that power and then scale it as well. Privacy preserving by having this hardware memory encryption by default. In this case, we utilize Intel SGX in this case. And then obviously the internet access with the HTTP requests. So these are some use cases, but has anybody, I see a question. So how does it choose how to distribute so there's a question on here that says, how does it choose how to distribute the work between the workers? Typically, when you as a Phat Contract developer, there's going to be multiple clusters that offer some type of computation. And if you want a percentage of that computation to run your Phat contract, you will then take your Phala tokens, stake it behind that cluster, and then you'll get that much of a percentage to run your Phat contract. So essentially, it's going to be dictated based on which cluster you choose to deploy your Phat contract. And from there, it'll randomly select which worker that is available to be able to run that work. If you want to get like even deeper and deeper into like the real low technical like specifics, I would advise you to go into our Discord and ask in the dev channel just to like understand like the lowest technical details. But that from a high level is how we typically are able to like distribute the work between the workers. There you go. So I put a link in the chat for you to jump into our Discord and then ask some questions. No problem. Yeah. So here on this slide here, it's kind of going into some of the use cases that you can do. Some of these use cases will be more available later on as we open up more functionalities for one of our products called SideVM, but I won't touch on this much at all, but this is how you'll be able to get more of these like Center 2 blocks here where you can have some true fully scalable use cases where you're like scaling your like computation power with like NFT image rendering, AI model training, and then for like low latency, maybe like running a metaverse backend or a game server. We've proved these as a concept, but right now it's not available. So just to like kind of put the ideas in your head that some of the capabilities will come, but later on. Some of the more like reachable ones right now, like access to the internet by running like a bot, or aggregating any kind of data in, or running some computation on top of like some data that you get from an Oracle. So you could build like your own customizable Oracle, and confidential. So maybe you want to run like some kind of ghost auction, or like a dark DEX pool. We do have like a product that I'll show here in a second. PrivaDex, they're one of the products that have been built on our protocol. So I'll go into some of the applications on Phala just to give you just some brief information about some of the products that we've built. Here is SubBridge. So SubBridge is an XCM router. We utilize Sigma Bridge. I think that's what the name is now. But it was a chain bridge in the past, but we're able to use that bridge and then take our Phala token that's on like our on Ethereum, like our EVM token, take that, wrap it into XCM message, and then be able to route it to the various open HRMP channels that we have with other parachains in the network. So in this case, we have way more now, but this was like a image I took in the past of us like being able to move our token between Karura, which is Kala's parachain on Kusama, Moonriver, Bifrost, Parallel, etc. I see there's a question. Oh, nice. Okay, another one here is our delegation to a stake pool. So if you don't want to build, or you just want to stake behind a computation, like a computation pool, then you can go here. You can go select one of the computation pools, and then you can earn some yield off of staking behind these computation pools. We also have a vault that we built as well. These are just some of the tools that we've built out. Follow World, which is our like progression of your interactions on Phala Network. We have this Soulbound 2.0 NFT that we built through the Remark NFT palette, and then with the integration with Linen Tree, we're able to aggregate some data in from your Web 2 and Web 3 profiles and generate these personal attributes for you. Is it layer 1 to layer 1 bridge? I mean, ETH to Polkadot chain. Yeah, so we utilize the layer 1 bridge to Ethereum using like the Sigma bridge or chain bridge, what it was called in the past. And then from there, the sub bridge part is where we're able to wrap the wherever you want to route your token into an XCM message, and then route it to the parachains that we have an open HRMP channel with. So that's how we're able to take our Phala token that's on Ethereum and then move it into our Kala parachain, and then whichever parachain that we have our Kala token on. And then we're enabling other ones, but if you go in, like in Discord, you could probably ask to get a little more information. I think we'd be able to provide that information. And after this, if you ask me questions or reach out to me personally, I'll get you all that information as well. But yeah, this is just kind of like the next part with our Remark, like using the Remark NFT palette to be able to create these equipable NFTs. And this is what I mentioned earlier, PrevaDex, one of the first Phat Contract builders, and they're part of our builders program as well. They've done a really good job here. You can check it out and try it out as well. It's prevadex.xyz. And then these are some like use cases that you could build, like DevPHAse, which is a password manager, SecretMD, and then a bot here. So let's start with like a short little demo about Swanky, and let me go back again. Swanky and DevPHAse demo. So the first part I'll show you will be me showing you like just the initial things that we have with the Swanky Phala integration. So it's very bare minimum right now because we have some refactoring to do to be able to have like dynamic updates so that our DevPHAse tool can be more flexible, so that it can work really well with Swanky and give you like more of a similar experience that some of you have seen with the Astar demo. Let's see if I can share. And can everybody see my screen, or is it big enough? So right now I have Swanky already downloaded here, and you can see I have like the 2.1 CLI version, and then you see this part here where it says the plugins, list installed plugins. I think I installed it already. Let me check plugins. Nope, didn't. So typically what you would do to install a plugin, if you were to build one through the Oak Cliff framework, you would have your plugin, and then you would put plugins. And if you want to install like the actual package from like npm, you install. If you're developing locally and you have your repo, you just use a link. But I'll install the one that I just recently deployed. It's the npm package is at Phala Swanky, dash plugin dash Phala, and then it'll go and install the plugin. It'll have some stuff here, some dependencies. So you can see that we have version 0.0.2-beta 5. Clear this out. Go Swanky plugins, and now you can see that here that we have the plugin installed, right? From there, you can now have access to Swanky Phala, put help, and this is here. It'll say like Swanky plugin to set up the Phala developer environment for Phat Contracts. One caveat in to think about though is we don't. If you have like a MacBook with the M1 chips or M2, you're not going to be able to run a local testnet, but you will be able to build and compile your Phat contracts. I'm using my Linux machine right now, but just to keep this in mind, like if you run into any errors or anything in the whenever I'm showing like the DevPHAse portion of the demo, but the initial thing that we have here, let's say like if you want to look at all the different available commands, you just put like a -- help. I forgot to put Phala. So this would be like some of the commands available for the account. So you could list the accounts that you have. You could create an account. I think they should. Yeah, these are like the ones that aren't working right now, but I will show you the first initial part that we have going. Swanky Phala init, and does a Swanky plugin play nicely with versions of npm yar, or are there known versions to avoid? So there's a question in here that was talking about like Swanky plugin play nice with most versions of npm and yarn. I would say that it like dependencies are always like a I don't know, like a tricky thing. I think that's like some of the things that has been really hard about taking the Swanky plugin or Swanky CLI tool and then plugging in another CLI tool into Swanky. That's the hardest part, is like keeping these versions compatible and you're not getting like any kind of unexpected behavior. Like for instance, last night I was working on this and a lot of unexpected like behavior started happening, and had to like really pivot on some of the things that we were presenting. So it can get really tricky. I would say if you're building like a plugin for Swanky, it would be best to maybe like conform to whichever version of Swanky you're working with. So if you're going to look at like the Swanky core and make sure that all of your packages are in line with theirs, then I would say like that would probably be the best way to like keep your tool in compatibility with Swanky. But that's just kind of like from my opinion, and just kind of like my experience like working with everything, because like just trying to balance two different CLI tools, it can get hard. No problem. So typically, like the first thing that I created would be creating like a new project. So I'll call it new project. Let's see here. So here it'll be similar to what you see with the Swanky CLI tool. You'll have like a contract language you can choose from. Ours is pink, which is like Phala's ink. It's just like a slight variation, but it's still ink, the ink programming language. And from here we have like a few drop downs here. We have like a blank one, Flipper, like the classic Flipper smart contract, like the ink contract, HTTP client. This is just like a test one, Phat Hello, which we'll be able to query the balance of a Ethereum address, and then signing, which is deriving a key pair, and being able to sign and verify messages. So these are just kind of the templates that I've been building so far. We can do this. You can name it whichever name you want. I'll just keep it at Phat Hello. It'll look at your get name in your command line. So #warlock for mine. You can enter your email if you would like, and then from there it'll start checking dependencies and install all the binaries you need, and then also copy over the templates into your new project. So I can change into new project, and from here you can see all of the files that I have now that have been downloaded and moved in. The DevPHAse.config.ts file is important. Right now, it'll automatically, well, I can go in here and say, right now, if you try this out after this this little workshop, you'll notice that it says like latest here for your version. I would suggest to change this to, I think it's like DW, right? Yep. Nightly dash, pretty sure this is it. Yeah, 24. I would change it to this version for now, because this is like the last stable version. And whenever you run your test, when I show you later with the DevPHAse repo, these are the binaries that will allow you to like move forward with your test that you build with the DevPHAse tool. Because right now the latest version, like last night, I was getting a lot of errors, and I didn't realize it was the latest version that was actually causing all the errors. So just for anybody that tries this after, I would suggest change this version here. Let's see. So we can kind of like look in here, say, you can see I have my like cargo file here. Maybe I can just open CLion. Just to kind of show you the repo. It's kind of odd. I don't know if y'all can see it. It has this blue film over it. It's kind of odd, but just to show just kind of all the files that got downloaded. You have your test. This is the test that gets generated whenever you create your template contract, and then the contracts will be in here. Your cargo file, your lib file. Here's your binaries here, but I'm gonna exit out of this and then move toward. I need to. Sorry, there's something going on with this. Don't like it. One second. Sorry. So here's the DevPHAse tool here. I'm gonna kind of do it from the IDE, but I can show you I'll show the command in the terminal. But essentially here, what I'm going to show is me querying with the Phat Hello contract. I'm gonna query a balance here for this address, I generated the hex address because if you do it in here, you'll get like, say, like you'll get something like this: error invalid address, because it needs to be like the hex value. So typically we're going to be looking for like this result whenever we run this test. So I'm going to move this into play and see if I can. Everybody see here? So whenever you have like DevPHAse set up, you'll compile your contract, and with you'll, like, for instance, like I'm going to show like in the sandbox that we have, what the command would be like DevPHAse contract compile c Phat hello, and from here it'll compile your contract, so you'll get your like phathello.contract, phathello.wasm, and the metadata.json file. Let's see. And then from here, we want to then like test it. So based on the test file that was generated, I'm going to show like where we're going to be getting the expected value that I showed here of like this result with the account I have. And I'm going to be doing this in my like little local testnet. So it's going to execute these binaries, run a local testnet, configure the testnet with like our off-chain worker, register the worker, create a cluster, and then deploy and instantiate the contract in that cluster, and then execute the test. So that would be the command for that would be yarn DevPHAse contracts test -s. S stands for test suite, and this test suite is going to be called Phat hello as well. So here you can see that it's starting the node, started the P runtime, and started the Fairy executables. Now it's registering the worker, uploading the contract, verifying the cluster, and now it's going to start running the Mocha test suite to be able to execute the test. And then you can see here, should be able to query the balance of an Ethereum account. And you can see that here, 413-610-392-5787-60786. And that is the expected value here from Etherscan API. And that's just kind of like a simple example. And then to show kind of the UI version of this, I had deployed it already. And like I said, whenever I was working with this earlier, whenever you use the hex, the non-hex value, like just the regular address value, you'll get like error invalid address. But whenever you use the hex value, you get that same value here. So you can interact with it on our Phat UI and be able to put your account here. I just get the hex value for it. I think I printed it out here. Yeah. And that just happened right here. And also the cool thing about this, our Phat UI, is you get some logs here. You have some recent blogs, recent events as well. And the cool thing is, like, so I'm able to interact with this Phat hello, and then we have our the signing contract as well. So you just click here, you get right to the signing contract that you've uploaded and instantiated. So say I want to message like, hi from Encode Club Demo. And I'm going to sign this message. Let me just copy, run it. At the top, you'll see here this message signed, and it'll give me this here. And then I want to verify it. So let me just put that there. And oops. I think I put hi from Encode Club Demo. Let's hope so. False, because I didn't put the right word in. So maybe it was. Potentially. True. See, yeah, so I just was missing the capital letter, but it's able to verify. And then you can also run your own test here as well. But are there other questions from the audience? Just from their like just from this like short demo. I know I only have like I think like 13 minutes left because I wanted to open it up for questions and maybe some other things and see what people are thinking. Oh, so like let me go into the code for this part. Let's see. So here's the signing contract here. So I'm not sure if I know how to. Can you read the code?
Yeah, I can see it now. It's good.
Awesome. So the signing is from a derived key pair here. So we have the chain extension signing here, and you can define a signature type. So I think the options are like SR25519 ED, and there's like the Ethereum ECDSA as well. But here, whenever we instantiate the contract through default, it's gonna derive a private key from this little here, like a spoon of salt. So a little salt here. And then we'll take that generated private key and then get the public key, and then we'll store it in our contract. And since they're utilizing the since we store this inside a secure enclave within the cluster, you'll be able to store some like secret keys here. So in this case, we stored like the private key and the public key. But typically, if you want to generate something that where you can just call the chain extension signing key and then just derive it on the fly, so you don't have to store it in there, that might be a better way. But from here, when I called that sign, I gave it a message, and I called the sig, like from the signing extension sign, and I gave it the message in bytes. I took my private key here that's stored in the contract and the signature type, and then create a signature and return that signature. So that was that hexadecimal that was returned from the sign. And then when I verified, I put back the message that I had originally put. So the first time I put the wrong message, and then I provided a signature and it returned false. And whenever I had the right message with the capital H and the signature, it returned a bool that was true. So this is just like very, very boilerplate, but this is like kind of how we did one of our original demos to do a like an attestation on GitHub, where people could put their on the gist in GitHub. You can create attestation, and then wrote some logic here to be able to query that through a HTTPS request, grab it, see that it's signed by the contract where we gave them a like an attestation to submit and gist, and then we were able to verify that they actually submitted the attestation from their account, and then ran a test like that way. So there's like some small things there. Another thing, do we need to serialize and deserialize to interact with on-chain data? Oh, so we do have like libraries for this. So like the pink Web3 crate and the sub RPC crates, we did a lot of like the heavy lifting there for you. So you can leverage those to be able to get all the the parsing and whatnot of your information that you're querying from like the RPC nodes on like a EVM based chain, and then being able to take that data and then do some computation over it. You might have to, like, based on like what you build, you might have to do some like custom let's say like parsing of that data. But we have like the pink JSON, I think it's called like pink JSON, that handles a lot of the parsing of the data as well that you interact with off chain. Oh, hey, Funky, I see you. Nice. Yeah, I cut my hair. It was too much. It was way. It was like middle of my chest. I couldn't do it anymore. Are there any other questions?
If not, I think then we can kind of end the session there. I have a few announcements to make anyway. So, but firstly, I just want to say thank you so much, Joshua, for speaking today. It was really great. You went through, I think you went through so much in a very short amount of time. So that was really cool that you'll be able to kind of put all of that together, especially with the demo, even though I know there's probably so much more that you'd love to share. But I think it was a really good start for, especially for people who want to, who are getting into this and are a bit more new to this. Okay, sorry. I hope you guys can hear me clearly. I've got a little bit of background noise, but no problem. So just coming up, we have a Polkadot Hackathon coming up. So I just wanted to make sure that you guys know about this and are excited and have signed in. I'm just going to pop that link in the chat. Please do give us, please do sign up to this. There have been so many things that we've learned across this entire Educate series. And so it would be really awesome if you could put those skills to the test in this hackathon. It's starting in a couple of weeks. And pretty much, yeah, just reach out to us, give Joshua a follow on Twitter, as well as Phala, just to keep up with that. And yes, stay tuned. Sign up for the next session, which will be this Thursday. And I think that's pretty much it from me. Thank you so much again, Joshua.
And I will say too, I participated in the Encode Hackathon in 2021 in November, and that's how I got the job at Phala. So definitely.
Wait, no way.
Yeah.
That's sick.
Yeah. So it's like really successful. So I really love the Encode Club.
Oh, that's so kind of you to say. I didn't actually know that. That's so awesome. So essentially, what Joshua is saying is, do the hackathon, and you'll do really well. Awesome. Okay, great. Well, I will close the room now. Thank you all so much for coming. But if you guys want to keep chatting in the chat, as you may already know, that will still stay up. But thank you guys again so much. And I'll see you all on Thursday. All right. See you guys. Bye.